Hello, Tube. Hello, Room. Hello, Zoom. We're picking up from where we left off last time. We've done forward difference for the variable, for the constants, and for addition. And Clemens's mission is to figure out what's going on with multiplication.
Excellent. So thanks, Connor, for giving me this mission. So let's hope we'll end up in a successful state. So indeed, we have defined last time the diff operator for, as Connor just said, variables, constants, and plus. And now the question is, what happens with times? And the strategy of this definition was, we are not defining first everything and then prove something, but we first look at what should this difference operator actually satisfy, which was this statement here.
You'll need to share your screen on the zero. On the zero. Yes. At the moment, you can't just see it behind me, but it'd be better.
That's a good point. 1 second. Okay. How do I go to the okay, here we go. Now entire screen. What could possibly go wrong?
Fantastic.
So now I have to get rid of all that stuff somehow.
Hide, floating, meeting controls.
Excellent. So now the statement that the difference operator should satisfy was this one here. So if you evaluate a formula at the successor of n, you should be able to compute this by compute the formula at n and compute the difference operator at n of p at n, and then the sum should give you what happens at step n plus 1. You take the value at n, the value at n of the difference operator brings you to the value of p at n plus 1. So I copy this just for the fun of it, because we're now going down to the case that we have to deal with, namely the multiplication. And if we have to deal with this, it's always good to somewhere put the inductive hypothesis. So let's carry this like this. This was not good, but we will get there. So this is indeed the inductive hypothesis that we know for, not for P, but we know it for Q and R. So you see, we are proving something here about the formula Q times R. So we have the inductive hypothesis for Q and R. So we know, for example, that we can use that this holds. Okay, so what do we have to prove? We have to prove that the evaluation of this thing equals exactly this. We tested this and arrived at the following. Evaluate Q of S of n times evaluate R of S of n. So the times from the formula became the actual times via the computation is equal to whatever is on the right-hand side here. So how could we continue now is the question. And in an inductive proof, somehow the answer is that we want to reach the inductive. We want to somehow actually, at least for half of the work, just use the inductive hypothesis. And so we have an evaluate Q of S of n in the thing we want to prove. And we know that this holds. So the idea is now inductively. So the idea is now to explain, to ask that we should go via the inductive hypothesis. And we do this via our favorite command, which is by root. So we have to basically direct ask to the inductive hypothesis. So let's check where we get with the by root. And now the bracketing will be always a nightmare, but let's see what happens. So what I want to tell ask is actually saying, instead of proving this stuff here, try to substitute those two numbers via the inductive hypothesis, so to speak. So I'm going to replace this with this. So let's put this here. And then we have times, obviously. Okay, sorry, this times copying is not very efficient. And then we have again the inductive hypothesis, but this time for R. And then what happens next is a question that I don't dare to ask. You always have to close the parentheses. So let's just send this off, and then something terrible will happen. Namely, the box will resize, and I'm going to, 1 second. Pull it off again. Okay, let's see. Sorry, what happened now? Something bad happened. Sorry, what uh, there's something subtle happened, I think, but I don't know what it is. It
looks a lot like it's
excellent.
for didn't happen.
1 second. Can I do control? No, let's put revert.
Question mark. Yes, remove the question mark.
Okay, thank you. The question mark, bloody question mark. Thank you. Thanks for the lifesaver.
Right. This looks more like it.
Indeed. This question mark. Good. So now what we got via this route is two new things that we have to prove, as is usually the case. I mean, ideally, the route should only give you one in many cases because the route is chosen in such a way that one of them is trivial. But one of them in this case is only almost trivial. And it's the first one. Because the first one basically has 2 times the inductive hypothesis, but applied under a plus. So the first case, I think, under times, obviously, because we are now in the times case. So the first case we should be able to do that somehow with under times. Somehow my brain is really into plus. I want to kind of run back to the plus case because I want to hide somewhere. Anyway, send. My problem is that I didn't drink that coffee that is standing in my office, but so let's see what happens next. So this is now actually proven, which we are all happy about, I hope. So now we have to deal with the second part, which is less obvious. Especially, it's obviously less obvious because we have no no clue what on earth this is, right? So this is actually the half of the this is now the equation where there's still this thing which is unknown. So we have to somehow figure out what that unknown thing is.
Yeah. But it's not too bad because you can see stuff you do know about. The evaluate Qn times evaluate Rn on the right-hand side. So you need to figure out how to put that up on the left-hand side. And then whatever's left over, that's your definition.
Excellent. And it's even slightly better than this, because if you look at the first part, you have these 2 sums being multiplied. And the last term of the first sum is evaluate Qn, and the second term of the second sum is evaluate Rn. So eventually, if we multiply that out, we will get something plus evaluate Qn plus times evaluate Rn. And then we have a sum that will have to be equal to the first part, which will then give us the definition. So we first have to multiply it all out, and then we just compare the terms, and we realize one of them is the same, and the rest has to be the definition of whatever the difference operator does to Q times R. Okay, so let's have a look how we do this. I can do it the slow way or the fast way, but I think probably it will just break anyway. So let's have a look. So this is done now by multiplying out. How do we multiply out? I would just want to scream at the computer, but this is not the way. The way to do it is to say by root and then just tell that we want to go via that multiplied version, basically, in the first instance. So let's do a by root here. And then what? So we have this term. So this is basically A plus B times C times D, and you have to multiply it out. So first we do A times C plus A times D, and then B times C plus B times D. So that's what I'm just now writing into the by root, that this is what ask should ideally do. So we do, this is the first one, and I'm copying it twice to make it slightly quicker. So this needs to be multiplied with the first one of the second sum, and then we sum it with whatever happens next. Oops, here's evaluate Rn. And then, so this was now the first, sorry, somehow the whole screen always keeps dancing in front of my eyes in this time of the day. Now we go for the second term. The second term has to be also multiplied with all of the things in the other sum. So we have this one and this one, and we have to copy that in. And the suspense in the room is audible. So now there is a way. I think, wait, this could actually lead me somewhere if I now would just press send. However, should I do it or not? I mean, there's two options. I can now do the bracketing right immediately. I think
I would fix the bracketing.
Okay. So basically, the bracketing also makes it clearer what actually happened, I think. So we just can do this. I'm just grouping it now into the way we multiplied it out. So we have first here, this is the stuff that happens if you multiply evaluate diff qn with everything in the next sum. And this is what happens if you multiply evaluate qn with everything on the right.
Multiple line breaks might be very useful.
Line breaks are over it. If you work long enough with this, then line breaks will become over it. Okay, good. I think sorry, these are not very helpful line breaks. Let me see how I can make them more helpful. I think it would be better not to have that line break, but then it doesn't fit. Let me move that slightly back. So this is exactly, for example, what happens. My spell checker tells me this is crazy. Sorry. This is what happens if you multiply evaluate Qn to everything in the next sum. First to the diff Rn and then to the evaluate Rn. I hope this is clear. So this is really just multiplying it out. Okay. So now I hope this is really just multiplying it out, because I might very well have introduced some secret mystery error. But let's see what happens. Does it look like a mystery error? It slightly does, but hopefully not.
Looks like a mysterious error.
Sorry, let's briefly go.
Yeah.
I'm not going to accept this because there's some issue here. Oh, wait, I forgot the bracket, I think. Wait.
The closing bracket after the value it did QN for the multiplication, that one is extra.
Yes. Okay, thanks. So yes. It helps having some form of syntax highlighting. Wait a second. This is good now. Yes. Good. Let's have a look where we are next. So now we have two cases to consider. Sorry, where did we end up? Here, so we have that this is the original product, so to speak, on the left-hand side. This has to be equal to the multiplied out version. That's what's written here, basically. So this was the original kind of product that we were multiplying out, and these two lines are what we would hope is the result of multiplying out. So then the hope should be that we just do a test. And then God knows what happens. Wait.
May not be God, but I do know what happens. Namely, nothing.
It's not okay. Let's not listen to God. Let's listen to Connor instead. So 1 second. Wait, what happens next?
Um,
Are you sure that nothing is going to happen?
um,
Wait.
Pretty damn sure. Everything's stuck.
But this is just A plus B times C times D, basically.
Yeah, you know both individual distributive laws, but you don't know the combination of them that multiplies out.
So you think
You can prove multiplying out.
I see.
Helpful helper.
Oh no.
Um,
So are you saying I need to prove multiplying out? Okay.
yeah. You look what you've given. You've just been given distribution from both sides.
Yes, but on the other hand, in my Emacs it worked. So I wonder whether I had it somewhere.
You had a helpful extra result, which you should now go and steal from the email.
Oh, the question is whether I can find my Emacs. But let's just double check indeed. Did I have? Ah, here we go. Indeed. Ah, so what? Oh wow! Sorry, what's happening here? Are we going to prove that, or are we going to?
Um, copy that from your Emacs into the buffer, into the ask box above the proof that you're currently doing. Run both of them because then you don't have to remember which one is which.
Copying it into my Emacs will be a nightmare, but let's hope it works. Let's see.
Is it there?
Yes, it worked. Yes, so we need some rules of multiplying out, basically. So A plus B times C plus D is exactly what we want.
Yeah. So you can see both of these proofs of different ways round of multiplying out use the individual distributive laws twice. One of them is left then right, the other one is right then left. And this gives you the four-way sum that you need. You should just then be able.
I think then I should be able to do the test, right?
No, you should actually even just be able to delete the first sub-goal because ask will just say, oh yeah, that's fine.
Yes, okay.
Multiply out now.
That is actually right. But what happened now? Sorry, here we are. Should I press send?
You should try deleting the first sub-goal.
Okay. 1 second. Where was the first sub goal? The first sub goal is this one here.
That should now follow by multiplying out.
Yes, so Ask did not complain, which looks good, in fact.
Awesome.
Fantastic. So the multiplying out worked, but we are still not done, right? Because we have to do the main thing in a way, which is, let's first have a look. We have to prove that this whole sum that we were multiplying out is equal to the thing on the right-hand side. So we have these four terms, and this should be equal to those two. And so these four, the sum should be equal to this sum. And so what can we see now if we compare these sums? Well, we see that we have an evaluate Qn times evaluate Rn and an evaluate Qn times evaluate Rn on both sides. So we have call that thing whatever x in a sense. So we have a sum plus x equals another thing plus the same x. So that other thing should be ideally equal to the sum of the first three things here. So that means that this thing we want to be equal to the sum of those three evaluations. So this gives us now the clue about what that formula here should be. Because it means just that that formula should, we can't just read off the solution, so to speak. That formula should be the sum of some formulas that we can read off that sum. So the first term here of this formula will be diff q. I mean, I copy this now up to the definition of diff. Noting that if I now paste what I wrote now, it doesn't make any sense, right? Because on the left-hand side, we're trying to define a formula, but what we have on the right is, of course, a number. So we need to find the number, the formula that if we apply evaluate to it, will give us this sum. And because evaluate distributes over plus and times, by definition, we can just do this. So the first part of the formula should be somehow diff q, and we turn the times into a times, and then we do the diff r here. And then plus another term, but again, the plus is the plus of numbers. We have to use, of course, here the plus of formulas. So we go to this plus, and now do a diff q times, and this is just r, because we just evaluate r. And then in the end, we get, careful, I should not just jump over the plus because otherwise it will be catastrophic. So we need again the formula plus. And now, of course, I deleted something. No, here it is. This is just q times, and then r. No, diff r, sorry, that would be bad. So what we now have is basically three terms. Oops. Three formulas put together. But the derivative of the product is kind of the product of the derivative of both plus the derivative of 1 times r plus q times derivative of r. Difference, not derivative. I shouldn't say derivative, I should say difference. Part of it because it's written with a double F. Anyway, so the point here is, now if you look at those terms, if you're briefly, like me, using the wrong word, you might recognize, indeed, those two terms, because that looks awfully like the rule for derivation that we learned in school at some point. But then there is this extra term here where you take the times of the derivative, which is actually here, this picture. So that is this extra term, which is marked now on the screen, is this upper corner here with corner head on the drawing. So we have these three terms now, basically. Yes. And I'm not sure what's happening next, but I think
it's all over but bar the bracketing. Yeah, once you do this, you'll be almost home.
really, I'm still not home, you think? Let's see what happens. Ah, yes, there might be a bracketing issue. Let's go for the send button anyway. So now at least I'm already home because it's defined, and that's what we wanted, right? No, I'm not home yet because I didn't prove that my definition does do the right thing. Let's see. Sorry, what happened next? Absolutely nothing happened, of course.
Yes.
But now, of course, are you allowing me a test?
Oh, yes.
Okay, that's good. I'm happy. I mean, test always makes me slightly happy because that clearly means that I don't do anything and the computer does everything.
Yes. As you become more accomplished as program.
And I have proven it.
Yes. Because it already knows. It knows about associativity.
Exactly.
Yes. So fantastic. Yes, as you gain proficiency and practice and program, there is a tendency to develop an almost pornographic joy at watching computers do work that you're not doing it. I feel this way about my marking. I use Ask to do the marking. And every time I don't have to do some marking because a computer does it, I think, fantastic. But anyhow, we've got there that final step. Ask noticed that it was a special case of plus being associative, and was just happy to say, yeah, fine, I'll fix the bracketing for you. So,
yes, I'm very happy about it.
Yes. So, I mean, there's a transferable lesson here, which is that you set up your algebra toolkit, and once you've got those bits and pieces, and being the fact that you have rig structure tells you what to prove to get yourself your algebra toolkit, and then you can fight your way out of the kind of multiplying out and the reassociating brackets that becomes available to you. But here we are. We've got forward difference, and we started out not knowing what it was, right? So this is also a key lesson, is that when you see a problem of the form, define this and prove this stuff about it. The whole point is that you don't know how to make a definition. So don't think that's not fair, or am I supposed to know this definition already, or all of those sorts of things. No, the point will be that the things you're asked to prove about the definition will constrain your choices of what the definition can possibly be and enable you to do the detective work to figure out the definition. So yes, we're at the stage where I expect you to be a bit more of a detective and to figure out what the definition has to be, rather than just being provoked to recite a definition that's been drilled into you. So, new things, weird things that have that do something are kind of valuable here. I wonder, we've got, what, 15 minutes or so. Do we try and do the shift thing?
Yes.
Can you send that code somewhere helpful, like Teams?
Yes.
Or just shove it back in an Emacs buffer and mail it to me later.
I just better put it on Teams.
Yeah.
Just in the general channel.
Yeah, get yourself a code block and
Post in
paste it
channel, indeed.
Yeah, code block. Right. Yes. So, one important lesson that we need to get through in semester one of any computer science degree is to teach you to communicate code as text rather than as photographs. Right. If you sent me a picture of a program and ask me what's wrong with it, and I can't copy the code into my own computer because it's a picture, not text, I will do some very serious voodoo on your arse. So, that's pens and dolls time. You know. So Teams allows you to post code as code. So no pictures. Text. All right.
Okay, I think I just checked whether I think this is everything.
That's everything in by the looks of things.
Okay.
Cool. I'll fish that out and write it up in a bit. So shall I jump in and mess everything up?
I think so.
Right. So let's see.
Control C and Control V are your friends.
Good.
And Control X.
And you have tap, click, and scroll works the other way up. I'll try not to do things by accident.
Or you go to your computer and do it like there. But it's up to you.
Yeah, well, let's stick with where we're at.
Okay.
Let's look here, but also at sorry, YouTube, the diagram that's on the screen, but I'll maybe.
That was also lost.
Yes.
The last lecture on YouTube, I think.
Yes. So here we've got these three terms. Right. And my point is that here, I'll just do some rearrangement. I'm going to undo your multiplying out. Oh. 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 No. That was bad. I wanted
Sorry,
to.
what do you want?
I wanted to do a forward delete, but I don't know how to do that on your computer.
A forward delete.
Yes, as opposed to a backspace.
I understand. I mean,
Yes.
I never did forward delete.
Yeah. Okay. So all I've done here is taken out the common factor, and we've got a diff r plus r. So I've just undone a little bit of the multiplying out. And you can see that diff r plus r is otherwise r for the next input up. That's the definition. So what we know from that point of view is that we know how to make to turn a formula into the formula that gives the output for the next input up, if you see what I mean. So what formula gives for the input n the formula that r gives for the successor of n? That's the formula we figured out a few lectures ago was called shift r. Okay, so what's going to happen is that I'm going to press send, and Clemens's lovely proof will fall to pieces.
Indeed.
And then I'll have to fix it because I made the mess. So, how much trouble am I in?
I think we would be in real trouble if we would still work. Did you already accept it?
I haven't,
Okay, good.
but now I'm going to accept. So what's happened is not a lot. The test that we ran to expand the definition of diff has not left us, it hasn't just come out straight away. So I still have a bit of work to do. Let's see if we can just get a look at what's happening. So on the left-hand side, I've got this fully multiplied out piece of business, just spending space like nobody's business. And on the right-hand side, I've got some things I like and some things I don't. Okay. So I like the two things that are on the right. You can see I've got the last two terms in each sum are the same, just as we had before. It's just that the bracketing isn't quite helpful. So my first move is going to be a by root, which fixes the bracketing. All right, let me see if I can.
Which side do you fix the bracketing?
I'm going to adjust the right-hand side. Control C to copy?
Yes. Control V to paste.
Control V to paste. It's almost like
Windows.
yes. And then I'm going to put an extra set of brackets in here. And one direction of that should be fine just by associativity, which ask knows. So tension is palpable.
Yes.
Yes, one sub goal. That's good. So now what? Again, I'll stick in lots of line breaks to see where we're at. We've got a bunch of terms on the left. And we've got that's the shut up alarm. We've got this thing on the right. And so we can see that the outermost pluses here line up. So if I say under plus, some of the annoying business should go away. If I'm lucky, I am lucky, or rather, I've done this before. Right, so we now have, yes, it's where the line breaks are in an annoying place. Okay, so now this thing here is evaluate of Shift R at N. And I know a law about that. I know that I can change the right-hand side. I'm going to pick up the right-hand side, copy. My fingers do terrible things.
Yeah, I know what the problem is.
And then this thing here is evaluate R at,
Oh, what did happen?
I just hit page up instead of
Yes,
up.
I do it regularly, but
No, I don't want emoji.
it's some emojis.
Yeah.
I think if Ask could understand emojis, maybe that's a new feature.
Yes, it could do smiley faces when you prove stuff. Right. Oh, see, I messed up the syntax of that.
Oh, wait, what happened?
I'm just worrying about line breaks. I think I'll try that again. But it's clear that
It looks good. I mean, at least there's no fatal mistake.
so that's fine. This is going to be under times. And
Yes.
then I think I might have to bail on this because it's time to kick out. I will tidy this up. We're annoyingly close to it. The box for your 1-minute papers is by the door. And sorry, YouTube, we'll fix this next time around.
For the keys.
Yeah.
Yes. Thank you.